what we would do is it's a two-step process. First, we take the value at the beginning of the array, which of numbers. Well, what's this? I'm going to grab that. Come down here. I'm going to take that. I'm going to take the number at the beginning. And move it into where we found the smallest number. And then I'm going to take the beginning and set it equal to the smallest number. Now the reason this works is we can do this so simply is that the smallest number allows us to change the position of those two numbers because it remembers it. This is a very common pattern of changing values. You have to have a temporary place to put your information. So we already had the smallest number at this index, so we didn't have to save out the value at this location to a number because we already had done that. So now I'm going to go up here. I'm going to grab this. I'm going to move it down here. I'll copy it down here. Okay, we'll print that. Okay, so printed the first one, printed the second one. Now the only real complaint we've got here is to make it clear what has happened. We really sort of put in a space. So we'll just do that to make it perfectly clear that the 4 has indeed moved to the front. There we go. We've got a 4 in the front and the 10 has moved into the middle where the 4 was. Okay, so now that we've done that, we could go and get all excited and do this. Now, what am I doing? Well, I already know that the smallest number is at the beginning. So I will just move instead of looking at the very beginning, I will look at the next number beyond that and just find the smallest number again. So let's give that a try. And the next smallest number is 7. We're on to something here. And I could go and just copy these two down again. Put this here. Change this to 1. Okay. I'm going to clean that up. I'm going to take this code here. Move it to the bottom. Clean up the formatting. I'm going to, okay, we're going to run it once like this. And so here we go through, we find the 4, we move the 4 to the front. We go through, we find the 7, we move the 7 to the front. Okay, so begin to see that there's a pattern here and that this all begins to make sense. This is something we should be able to do with less typing. So let's first take out that print statement. Okay, let's take out printing the smallest numbers here because they are useful only when we're running the program. And now we want to talk about what is the program doing. So pull this down. So here, okay, let's take this circle, put that up as a blank. We're gonna put a comment here. So that we know that that is not code that we are interested in. The code we are interested in is here. So let's take out a few lines so that it is okay. So we create a smallest number and a smallest index, and the index we set to 0. We go through the numbers from 0 to 8 looking for the smallest number. When we find it, we take that smallest number, we put it in 0. Then we go and we look from 1 to 8 for the smallest number. When we find it, we make the we swap them again into the 1 position. Now to have made this 100% the same, we should have also gone, we got away with it this time, but this could be a bug. We should have initialized the index. That would have that probably would never be a problem, but that's the kind of coding mistakes that lead to problems. So you're better off getting into the habit of catching that kind of stuff, variables that weren't initialized at the beginning. If you don't initialize a variable at the beginning, if nothing else, it shows that you're not thinking all the way through to the possible valid values for that number. So we've got 2 arrays here. This one, two for loops. This one at the top and this one down here. And you'll notice that they are identical. They don't need to be duplicated if we can be smart about this. So what do we need to do? Well, if we go and we take this on to doing the third number, we would take all of this code here. Let's do it again like that. We would come down here. We would paste it. Back this up. And we'd make this a 2, that a 2, and that a 2. And then we'd come down here and we'd make this a 2, and this a 2. So now we can indeed begin to see, if I go and I mark these things, that we've got a definite pattern here. Up here we deal with zeros. Down here we deal with 1s. Down here we're dealing with 2s. Okay, and let's go and run this sucker. Work. Please work. Okay, and yes, we've got the first 3 numbers is all we've meant to sort. 0, 1, 2. The 4th number is already in order. So you can see that this behavior is getting us a sorted loop. So what do I want to do to make this not have to keep repeating this comp code all the time? Let me show you. So what we need is, because we can see that our numbers are going from 0, 1, 2, 3, they're going to go all the way up. So we need another for loop. For int outer loop is equal to 0. Now it's going to be less than 8. And we'll add on to it. And we'll put in a squiggly bracket. Now, we'll indent everything in. So we have an outer loop. The inner, this on here now goes from outer loop to 8. This two, I will explicitly move in. They can go away. Now, we'll take this guy away. We want to keep the declaration outside the loop. That's just a minor efficiency. Okay. And then down here, okay. These go inside the loop. So I'm going to take out that squiggly bracket I put there and move it all the way to the bottom here, next to where we showed that we had jumped from one place in the loop to the next. So now we're here, and I'm getting tired, so I'm going to take that, I'm going to copy it, I'm going to take this 0, overwrite that, overwrite that. I'm going to take all of this code here, delete it. Now we'll see whether it works. Look at that. It worked. I'm so happy. Okay, so we've got two loops. This is a really powerful arrangement if you can figure out what are the two loops you want to use. So the inner loop goes through the array, finding the next number. The outer loop goes and moves us along the array as we put numbers in order.